Temperature conversions. Let's convert the following temperatures. Now in these problems, we're going to deal with three different temperature scales. The first is Fahrenheit. According to one story, 0 degrees Fahrenheit is the coldest temperature in the air in the city of Danzig in the winter of 1708 and 1709. So we're going to use that as our reference point for this scale. The second scale is degrees Celsius, and that 0 degrees Celsius is the freezing point of water, so that's the reference point for that scale. And the last scale is Kelvin. 0 Kelvin is absolute zero. There is no temperature lower than 0 Kelvin. The two equations we're going to use to convert between these temperature scales are these. The top one converts between degrees Fahrenheit and degrees Celsius, and the bottom one converts between Kelvin and degrees Celsius. So in this first question, they give you 98.6 degrees Fahrenheit, which is the average human body temperature. You can see in the picture at the bottom right that the temperature across your body is different. The parts that are particularly exposed to air, like in your extremities, are a little cooler, blue, than the parts very close to your torso. But the average body temperature is 98.6 degrees Fahrenheit. What is that in Celsius? Alright, well, to go from Fahrenheit to Celsius, we use this equation. So degrees Fahrenheit equals 1.8 times a degree Celsius plus 32. We're going to plug that 98.6 in for Fahrenheit, so we'll have 98.6 equals 1.8 times the degrees Celsius plus 32. Now, our goal here is to get the degrees Celsius all by itself. I have two terms on the right side. I have the 1.8 times the degree Celsius, and then I have the 32. They're separated by that plus sign. So first, I want to whittle it down to just one term. So I'm going to try to get rid of that 32. It's being tied to the degrees Celsius by a plus sign, so I'm going to do the opposite operation. I'm going to subtract and use the same number. If I do that to one side of the equation, I have to do it to the other. So I'm subtracting 32 from both sides. On the right, it's going to cancel, and on the left, it'll leave me with 66.6. That's 98.6 minus 32. So I have 66.6 equals 1.8 times the degrees Celsius. So now we still want to get degrees Celsius all by itself. It's being tied to the 1.8 by multiplication. So we are going to untie it by doing the opposite operation. We're going to divide. And we divide by the same number that it was being multiplied by, so 1.8. If I do that to one side, I've got to do it to the other, because we don't want to change the equation. And so it cancels on the right, and we're left with the degrees Celsius equals 66.6 divided by 1.8. If you plug that in a calculator, you should get 37 degrees Celsius. That is the average human body temperature in degrees Celsius. Now, what if you have negative 223 degrees Celsius? How many Kelvin is that? That's the temperature on the surface of Pluto, a dwarf planet that's furthest away from the sun in our solar system. Well, to go from Celsius to Kelvin, you use this equation. Kelvin equals degrees Celsius plus 273.15. So we have degrees Celsius. We're going to plug that in, that negative 223. So we'll have Kelvin equals negative 223 plus 273.15. Plug that into a calculator. You should get Kelvin equals 50.15 Kelvin. That is the temperature on the surface of Pluto in Kelvin. Here we've got 430 degrees Celsius. What Kelvin is that? This is the temperature on the surface of Mercury, which is the innermost planet in our solar system. So going from Kelvin to degrees Celsius, you're going to use this equation, which is Kelvin equals degrees Celsius plus 273.15. Now we have degrees Celsius, so we're going to plug 430 in for that. Kelvin equals 430 plus 273.15. Plug that into a calculator, and you should get 703.15 Kelvin. That's the temperature on the surface of Mercury. Average temperature. Alright, 43.0 degrees Celsius. What is that in Fahrenheit? This is the hottest temperature that has ever been recorded in Florida. Now to go between degrees Celsius and degrees Fahrenheit, you use this first equation. Degrees Fahrenheit equals 1.8 times the degrees Celsius plus 32. We have the degrees Celsius. So I'm going to plug 43 in for the degrees Celsius. So our equation now is degrees Fahrenheit equals 1.8 times 43 plus 32. So do the multiplication first. 1.8 times 43. That should give you 77.4. And now you can add the 32. When you do that, you'll get that the degrees Fahrenheit equals 109.4 degrees Fahrenheit. That is the hottest temperature ever recorded in Florida. How about -2 degrees Fahrenheit? What's that in Celsius? And this is the coldest temperature ever recorded in Florida. Going between degrees Fahrenheit and degrees Celsius, you use this equation. Degrees Fahrenheit equals 1.8 times the degrees Celsius plus 32. So we have a number for Fahrenheit, it's -2. We'll replace that degrees Fahrenheit with that. So we have -2.0 equals 1.8 times degrees Celsius plus 32. Again, we want to get that degrees Celsius all by itself. First thing we have to do is to get that term, 1.8 times degrees Celsius, by itself. So we want to get rid of the 32. The 32 is sticking to that first term, the 1.8 times degrees Celsius, through addition. So we have to do the opposite operation to unstick it, which is subtraction. So we're going to subtract 32. You do that to one side, you have to do it to the other. On the right, it cancels, and on the left, we'll have -2 minus 32, that's -34. On the right of the equal sign, we're left with 1.8 degrees Celsius. So now, we want to get degrees Celsius by itself, but right now it's sticking to the 1.8 through multiplication. To unstick it, we have to do the opposite operation, so division, but with the same number. If you do that on one side of the equal sign, you have to do it on the other. The 1.8 cancels, and we're left with degrees Celsius equaling -34 divided by 1.8, and that would be -18.89 degrees Celsius. That would be the coldest temperature ever recorded in Florida, in degrees Celsius. Thank you for your attention.